Hey, welcome to Jed Foster Maths. In this video, we're going to be talking about basic integration. Now, in the past videos on the calculus series we've been going through, we've gone over differentiation and all the basic rules to differentiation. And the next part of this calculus series is integration. So in this video, I'm hoping to explain to you the basics and fundamentals of integration calculus, why we use it, and to give you a better understanding of what this is. I'll be introducing you to the power rule for integration and how it is the opposite of differentiation. So what integration is, it allows you to find the area under a curve. So if we had a curve, that looks something like this, y equals ln x. What integration does is essentially you can pick any point on the x-plane, say we pick 2 and 5, and it will allow us to calculate the precise area under the respective portion of the curve, which would be the area as shown. Now this is so useful because not every curve is linear. This will be useful because not every function is linear. And with some functions, they're quadratics, cubics, they can be logarithmic functions, exponentials, and you get all these kind of weird shapes that you can't really calculate the area to very easily. For example, with this one, you could get an approximate area by dividing up into really small rectangles and calculating each rectangle. But that's not very efficient, it's not very accurate. It will allow you to get close to the answer, but not the answer. So this is where integration comes into play. Integration is a form of calculus. It was founded by Isaac Newton and Leibniz, a man from Germany who you might not have heard of. But they both came up with integration, and it is used to calculate the exact area under any curve. And this can be useful because you can find the area under shapes and other things as well, like you can calculate distances. Even in cars, your odometer and your rev meter is essentially integrating. As you're accelerating, that's your rate of change, which is differentiation. But your rev limiter would be integrating, if that makes sense. But let's just get into a few examples. So what's the basic rule for integration? Well, first off, we need to define it. There's two kinds of integration. We have indefinite integration and we have definite integration. So what's the difference? Essentially, with indefinite integration, we are not calculating the area. We're just coming up with a formula that will calculate the area under a curve. And this is the first rule you need to remember. Whenever you're doing a indefinite integral, you need to remember, the integral, you always need to add a constant on at the end. For example, if you have y equals 4x plus 6, let's say we differentiate that to y dash equals 4. Integration, and I'll explain the rule later, but I just want to show you this first. It says the integral of y dash is going to be equal to 4x. And again, you can see that we've lost the constant of 6 because when differentiating, any constant will go to 0. And because we don't know what that number is, we need to add it in at the end. Plus c. So don't forget to do that. Make it a habit to do after every indefinite integral. But that's why we add the c on at the end. So that's the first rule you need to know, is to add a plus c, because we don't know what the constant is. So what's the power rule behind integral calculus? Let's start off with a basic question. Let's say we were asked to find the integral of y equals x squared. So what the rule says for integration is when we take the integral of x squared with respect to x, that's what the dx means, by the way, respect to x. What we need to do, we need to take the power, we need to add 1 to the power, then divide by that new power. That's the rule to integration. So we know the integral, and we can denote it as capital F of x, is going to be equal to x cubed, it's going to be x squared plus 1 divided by 2 plus 1. And don't forget to add the constant of integration on at the end. So that's going to become x cubed on 3 plus c. So that's your basic power rule for integration. It's the opposite of differentiation. Just remember that. So let's look at a few more. Let's have a look at, if you got the question, y equals, let's say x cubed on 3. Let's write that as 1 on 3 x cubed plus 2. So let's say we were asked to find the integral. So write 1 on 3 x cubed plus 2. Write dx as we're showing this is with respect to x. So to find the integral, and we can see this is an indefinite integral because with a definite integral you would have limits on the top and the bottom. So for instance, a definite integral you could have 1 and 0. And with the function, if you're given something like that, essentially you're looking for 1 and 0. And you're calculating the area with respect to the x-axis between the limits. So that's what a definite integral is, and this is indefinite, but the rules are the same for both integration technique. For both integrals. So when we're integrating this, we can, if you want, one trick you can do to make this a little bit easier for you with the fractions, we can bring the constant out the front. So we can do 1 on 3, and then multiplied by the integral of x cubed, and then plus the integral of 2. And don't forget the dx at the end. So that's going to be 1 on 3, and when we apply the power rule to this integral, that's going to be x. That's going to be 3 plus 1 divided by 3 plus 1. And then we're adding on our integral of 2. And when you have a constant, differentiation says any constant is going to go to 0. Integration is the opposite. Therefore, 2 is going to integrate to 2x. Whatever variable we are doing this with respect to, that's what it's going to become. You're going to do 2 multiplied by x. If it was with respect to u or v or whatever, all we do is 2 multiplied by that, or whatever constant it is, multiplied by the variable. And don't forget to add on your plus c and write capital F of x to show that this is the integral. So when we solve this and simplify it down, we get f of x equals, that's going to be 1 on 12 x to the 4th plus 2x plus c. So that's the basic rule behind integration, and that's how you're going to use most of the time for the more basic functions. So let's look at something else, something a little more tricky. If we were given a question, y equals, let's say, 1 on x, how do you integrate this? So we can write it down. Y equals, and you know that's going to be the same as x to the power of minus 1 dx. And when we're integrating this, you know how you're adding 1 onto the power? You can't really do that here because it's going to go, because minus 1 plus 1 is 0. So what do we do? In any circumstance where you have something that's going to become 0 when it's to the power of, like 1 divided by x, when you bring the x up top, it's going to become x to the minus 1, which is going to become 0. So you can't really apply the power rule to this specific kind of integral. There is a rule for this. The rule says that whenever this situation occurs, you need to take the natural log to find the integral. And the reason this is because if you remember from differentiation, you know that ln of x differentiates to 1 on x. Therefore, it will integrate to ln x because it is the opposite of differentiation. So, the integral of this function, 1 divided by x, is going to be equal to ln of x plus c. So that's another rule to integration which you need to remember. And let's move on to let's draw a table and we'll go through a few different integrals, and you need to write this down so you can remember these. These are just going to be basic. But let's say your table of integrals, let's write it down. Let's say we have, we'll just let the I will stand for integration. We'll have our function here. So say we have sine of x. That's going to integrate to negative cos of x. So make sure you write these down so you can remember these and use them when needed. 1 divided by x, as we just did, is ln of x. And cos x integrates to sine x. So these are some of your basic integrals which you're going to be using pretty often. So make sure you have these written down. And we'll keep adding to the table as we encounter new problems. Alright? So let's say you were asked to find the integral of, and by the way, I want you to pause the video and give this one a go yourself. You're asked to find the integral of sine of x. So when we're integrating this, write it down, integral of sine of x dx. From our table of integrals, we know sine of x is going to integrate to negative cosine of x, and don't forget your plus c. So that's another basic integration technique. Let's do a few more. Let's say if you got a question of y equals x, let's say we get 3 over 4, actually, x times the square root of x. Then we'll do plus 1 divided by x plus, let's do sine x. So again, let's write our integration symbol in. We're going to have 3 divided by 4 times square root of x plus 1 on x plus sine of x. Don't forget to put brackets around this and write dx as it's with respect to x. Okay, so again, we could bring the constant out the front, but it doesn't really matter too much. Whatever works best for you. For this example, we're just going to work with it as it is. So when we're integrating this, we know that the square root of x is x to the power of a half. So x to the power of a half plus 1, that's going to be x 3 over 2. And an easy way to remember this is with your powers, because you're always adding 1 onto the power, you're simply going to take your denominator, 2. So you're going to take your numerator, 1 plus 2, divided by the original denominator. So that's going to give us 3 over 2. So it's always your numerator plus your denominator divided by your denominator. That's the same for any fraction when we're adding 1 onto the fraction. So we can say f of x integral is going to be equal to 3 divided by 4, and have x 3 divided by 2. Then we're going to have by 3 on 2. And again, if it makes it easy to bring the constant out the front, just do that, then you won't have to mess around with this fraction work. Plus 1 on x, as we know, that is ln of x. Sorry, I should have mentioned before. Always write absolute brackets around x when we're doing the rule for 1 on x becomes ln x. That's just another thing that we need to do. So always make sure you write absolute brackets around that. It's not a big deal, but sometimes it might matter. Alright. Then sine x we know becomes negative cosine of x. And don't forget your plus c. So we can simplify this down. Bring the 2 up the top. That would become 6x to the power of 3 on 2 divided by 4 times 3 is 12 plus ln x minus cos x plus c. We can simplify this even further. 6 goes into 6 once, into 12 twice. So f of x is going to be equal to 1 over 2 x 3 over 2 plus ln x minus cosine x plus c. So that's another basic kind of integral, and this is all we're going to focus on in this video. We're not going to go any harder than this, but in the coming videos, and the next video is going to be on integration by parts, and after that integration by u substitution, and then we're going to be looking at integration by partial fractions. So for now, we've just covered the basics of integration, and let's do a few more questions. So let's focus on a definite integral. So say you're integrating, let's just say 3 and 1. And you're given the function of, let's say, x squared minus 5x plus 6. So say we were asked to integrate this function to find the area under the curve. Probably going to look something like this. And what we're looking for is area between 1 and 3. So what we're going to be calculating is the area under this curve. So to start off with, we're going to do the exact same thing that we've been doing through the past of the video. So we're going to find the integral. It's going to be f of x is going to be equal to x cubed on 3 minus 5x squared on 2 plus 6x plus c. And when you're doing definite integration, you don't use the c when you're finding the integral. I'll show you why in a minute. So what we need to do next to find the area, we need to add in some square brackets, alright? So we're going to be looking at 3 and 1. So the idea is we found our integral. We're going to be looking at substituting 3 into this equation, and then we're going to do the exact same thing but substituting 1 into the equation. We're going to be taking that away. So what that looks like is we're going to have 3 cubed divided by 3, because we're substituting 3 where the x goes, and we're going to do the same with the 1. Taking away 5, again, times 3 squared over 2 plus 6 times 3. And you don't write the c in here because you can if you want to. And I'll show you why you don't need to. And then we're going to take away the same function, but we're substituting our lower bound in. So we're substituting 1 now into the same equation. So that's going to be 1 cubed, it's just 1, but I'll write it all in there anyway. Minus 5 times 1 squared divided by 2 plus 6 times 1 plus c. As you can see, this minus sign is going to distribute to the plus c, and they're going to cancel out anyway. So you never need to bother writing the plus c in when you're doing definite integration, finding the area under a curve. So you can either do this all in your head, you can write it down, use your calculator, but we've got what we need. So let's start solving this. So we're going to have 3 cubed is going to be 27 divided by 3 minus 3 squared is 9 times 5, 45 over 2 plus 18 minus, and then 1 cubed just 1 over 3 minus 5 over 2 plus 6 equals 2 times 27 minus 3 times 45 over, it's going to be 2 times 3, 6 plus 18 minus, that's going to be 1 times 2 minus 5 times 3 over 6 plus 6. That's going to be equal to 54 minus 3 times 45 is going to be, I think, 135 divided by 6 plus 18. And again, I'd suggest just doing this on your calculator. Doing it in your head's pretty hard. And then we're going to have plus 18 minus 1 times 2 minus 15 minus 13 on 6 plus 6. Okay, so let's work this out. That's going to equal minus 81 divided by 6 plus 18 minus, that's going to be 6. That's going to become that's going to become 27 times 1. So it's going to become that, then divided by 2 minus 13 plus 36 is 23 on 6. Then that's going to give us 36 minus 27. It's going to be equal to 36 minus 27, 9 on 2 minus 2, 23 on 6. Oh, which is going to be equal to 9 times 6 minus 2 times 23 over 2 times 6. It's going to be equal to 54 minus 46 on 12. It's going to be equal to 8 on 12, which is going to be equal to 4, 2 divided by 3. Okay, so that's equal to 2/3 units squared. You always need to write units squared when integrating, because you are, after all, finding an area. And another important rule to remember, if you get a negative answer, just take the absolute value and make it positive. Because the mathematics in integration is always gonna... I'll just show you for an example. If you were finding like this area here, it would technically give you a negative because it's beneath the y-axis, but... Sorry, beneath the x-axis, but because you're finding an area, you can't have a negative area. So you're always going to take the absolute value, make it positive even if it is negative. But that sounds good. I think we'll wrap up for this video. So that's just your basic introduction to integration. So I've shown you the basic power rules and few table of integrals. So I hope you learned. I hope this video was helpful, and if you have any suggestions or questions, just send me a message, leave it in the comments. I'd love to talk with you and reply to you and help you wherever I can in the subject of calculus and integration. In the next video, we're going to be talking about integration by parts, and I have a really nice method. It's not mine, but I really like it, and I'll be showing you both ways of how to do integration by parts. And essentially what that is if you were asked to find the integral of ln x dx, where you don't have that on your table of integrals. And it's just like, it's a bit like the product rule with differentiation. It's just a bit different, and I'll be explaining that in the next video. But for now, always remember, Jesus loves you, and I love you too. And I hope you have a great day, and hope you do really, really well in calculus and integration and maths in general. So, bye.